next thing that we are going to talk about are HR diagrams, or Hertzsprung-Russel diagrams. Hertzsprung-Russel diagrams are really useful things in astronomy because they let us compare several features of stars at once. Now, full Hertzsprung-Russel diagram lets you compare temperature, spectral class, absolute brightness and luminosity, so these four features all at once. And generally you'd have temperature and spectral class on the top and the bottom, and absolute brightness and luminosity on the left and the right hand side. And that's because they're very closely linked. So when we class stars together, it's often based on their temperature, and the spectral classes are therefore very closely related to temperatures. So I can have two different scales that mean very similar things on the top and the bottom. And the absolute brightness and the luminosity tell us about basically how much energy a star is being given off. The luminosity is how much energy it gives off per unit time, and the absolute brightness is how bright it appears to be. And obviously those two things are very closely related, so we can put them on the left and the right. Now, as far as the exam goes, they are only going to give you luminosity and temperature. But if you look for HR diagrams pretty much anywhere other than your textbook, they're going to look a little bit different, and they're going to have all four of these things on them. So I'm going to talk about ones that got all four on, just because it's easier to illustrate really. But you can just ignore two of the axes basically. So just a quick word on luminosity. It's going to be the one thing we know what temperature is. Luminosity we won't have come across yet. We will study this in a lot more detail later, but for the moment you just need to know it's a measure of how much energy is given out by a star per unit time, and that's it. We will look at this in a lot more detail later, don't you worry. What we've got here is a pretty standard Hertzsprung-Russel diagram, and in this one, like I said before, I've got four things plotted on it. So temperature on the top and luminosity on the right, and spectral class at the bottom, and absolute brightness on the left. Now, because they're only going to give you temperature and luminosity in the exam, I expect that they will probably put temperature on the bottom and luminosity on the left. But that won't really change anything, just where the label is. Everything else will stay the same. And the key thing I want to note is that temperature, I've actually got my lower values on the right and my higher ones on the left. So for the temperature scale, it increases from right to left, and you're going to need to be aware of that. Basically, what this is telling me is that the hottest and brightest things are in the top left. The hot and not very bright stuff is over here, and the cold and not very bright stuff is over here. And up at the top right, we would have quite cold but quite bright, and you're not going to find much right up in that top corner. As you can see, we've got a lovely thread through the middle that are the main sequence stars. And where they appear on here are going to depend on their colour. So our star is around about here with these sort of yellowy orangey ones. As it becomes older, it'll shift slightly up through the main sequence, and then it'll swing off over to the right and towards the giant section over here. And then after it's been a giant, our sun will end up down here with the dwarf stars. Larger stars, remember that they tend to be bluer and hotter, so they tend to be up here in this end, and again they will shift further up as they get older, and when they become supergiants, they'll shift over up here in their own little distinct section before they go on to do their supernova and their alternative endings to their life, which obviously won't be on here. So there are some very clear sections, and we can see the areas where the different stars are found. So there are kind of three key sections to this diagram, three types of star, losing the ability to talk, that I just want to highlight to you. Most of the stars are main sequence, and generally the hotter they are, the brighter they are, and that's the most stable part of their existence, and stars stay there for about 5 billion years, which is why it's the most populous down the middle. If we were to plot all the stars we knew about onto Hertzsprung-Russel diagrams, we would find that the most populous section would be the main sequence section. As the stars die, they become giants or supergiants, which are above the main sequence. So for both of them, if you imagine the main sequence as being that line down the middle, then once they leave the main sequence, they rise above that line, and that's where we find all the giant ones. And obviously that's where they're no longer fusing hydrogen nuclei, they're fusing helium nuclei or bigger, and that's why they are different size and colour and brightness. And eventually our small stars will drop back below the main sequence stars when they become white dwarfs, because they won't be very bright at all. They're just dim little chunks of rock that are still emitting a bit of light. So those are kind of the three sections. We've got main sequence down the middle, giants above, dwarfs below. So I'm just going to give you a real quick recap of why HR diagrams are useful. Basically, we can take measurements of stars to find their temperature and their luminosity. If we then plot them on a HR diagram, we can very quickly see what stage they are at in their life cycle. So that gives us a very quick idea of how old they are and what's coming up in its future. So what type of star it is we're looking at. Because obviously if I just look at the colour of the stars, I can't tell what they are. I can't necessarily tell from their brightness. But if I combine together their temperature, which is often their colour, and their, how much energy they're giving out, plot that straight onto the diagram, I can tell, are they in that main sequence line? Are they above, so a giant? Are they below, so a dwarf? So it's just very useful for helping us to classify the stage that stars are at in their life cycle. We will have a little look at plotting some of these, plotting some life cycles onto these diagrams. I think they're going to be pretty straightforward really though. It's just kind of an extension of do you understand how the life cycle of a star goes, because we can then plot those stages onto these diagrams. Now it does explicitly say in the specification that it links main sequence, red giant, red supergiant and white dwarf to this. So I want you to try and make sure that you 100% could describe where on the diagram you would find those different 4 life stages of a star. And that is it. Nice and short today. Remember, if you've got any questions, ask when you see me in class.